So now we will, I'll just mention the first welfare theorem, first fundamental theorem of welfare economics, so to say. In case of production, we have seen it in case of consumers' consumption, and now we will see it in terms of production. And then we will look at some of the important assumptions that are implicit here also. And then we will move into the last part of general equilibrium, that is the efficiency in product mix. Okay, and what we are in the end trying to achieve through all this. All right, so the statement is basically just adapted for production and nothing else. Okay, so the statement is a competitive equilibrium production vector is efficient for the economy as a whole. Okay, so that is the statement here. And the statement of the second theorem that you have there with you is basically, it remains unchanged. It is written taking into consideration everything. Okay, so if you want to have a look at the statement of the second theorem, then just look at the statement that you already have with you. Okay, so what does it mean? Now we have studied MRT, right? Or we have studied, let's say, PPF. On PPF, we have seen that the efficient equilibrium, that the equilibrium appears on PPF. And now we have this theorem, a competitive equilibrium production vector is efficient for the economy as a whole. Now, if I combine the meaning of these two, what I'm saying is that in a competitive equilibrium, okay, this is what I mean basically, that in a competitive equilibrium, it is impossible to increase the output of one good without decreasing the output of another. So that's what you're saying. So efficiency guarantees the fact that this part of the sentence, it holds true. That is, we cannot increase the output of one good without reducing the output of the other good. And the theorem says that this is the thing which happens in a competitive equilibrium. Okay. All right. So that is what it means. Now, about the assumptions. First thing that we will note is that in our discussion, IRS production function is excluded. Okay. So you have seen that I have mentioned while drawing the PPF that even we have CRS under which you may expect that the PPF will be linear. It may not because of differing factor intensities. Okay. So if factor intensities are different, then even with CRS, we will have a concave PPF. Now, with IRS production function, the problem is, so IRS production function is excluded. Why it is so? Why it is excluded? The reason is that if I include IRS, then what happens is that then it may happen that if I take some, if I reduce the production of one good and take out some input which are being used in the production of that good, and if I put that in the production of other good, then IRS will say that the production of the other good will increase more than, in terms of rate, more than the amount of input that I have given. Okay, so if that happens, then it will result in a non-convex production set. Okay, a non-convex production set. And given a non-convex production set, we will have a problem of defining an equilibrium which will have the nature or the features that we want it to have. Okay, so because of that, IRS production function is necessarily excluded from entire discussion. All right, and that guarantees that the production set that we will have a convex structure, which in turn means that our PPF will be concave. So this is number one, and number two is quite trivial. It was assumed in the other in the chapter of consumption also. That is, there is no externalities. Okay, there is no externalities, and in terms of production, what it means is quite easy to understand. What we are saying is that there is no pollution in a manner that will affect the production of some other good. Okay, so let's just say that if you consider car garages, they are quite polluting. They are quite polluting. Okay, they pollute the waterways heavily. So we are not considering that kind of a scenario. Okay, so in terms of consumption, you may not really think that externality is a very important thing, but in terms of production, you can easily feel, with the pollution levels that we have now with us, that it's a very important point, right? So we'll see that after studying welfare economics, that if we include externalities, what really happens. All right? And within this scope of discussion, I must say that what it basically says is that if you have an externality, then having a competitive structure and having efficient production are two very different things. Okay, all right. So that said, having pollution with production, okay, it creates a bigger problem. Okay, so having pollution with production, even ensuring competitiveness, doesn't guarantee efficiency. Okay, so we'll see that in a different discussion. All right, so now from this, we will move on to the efficiency of a product mix. And I have stated, or I've hinted rather, the equilibrium condition that we will have in that scenario. So earlier we had MRT, and even before that, we had equal MRSs. So in product mix, there is consumption and production will just say that they will be equal. So what is the efficiency condition here? So it's two goods XY, MRT XY equal to MRS X comma Y with two individuals. This goes to A and the other goes to B, right? So this is our efficiency condition. And obviously, assuming competitive economy, we can insert price here in this place, right? And we can write this. So MRTX comma Y becomes equal to PX by PY becomes equal to MRS X comma Y A, which will equal to MRS X comma Y B. All right, so that's the idea here. So this is also known as optimal composition or efficient composition of output. So what is our objective here in terms of, let's say, economics? What we are trying to say? We are saying that we are looking for that production plan. Okay, we are looking for that production plan which is consistent with the household sectors plans. Household sectors plans. Okay. So in essence, what you are saying is that if we have, if we are producing at a point, or rather we want to produce at a point where the rate at which in production X can be exchanged or transformed into Y is the same rate at which consumers will willingly exchange X for Y. Okay, so that's the kind of point we are looking for. And this condition, if this condition holds, we will say that we have got that kind of a point. All right. So let's look at the diagram of this condition. So we said we had Edgeworth box and we had PPF, right? Okay. So here you have X, here you have Y, and here the PPF, and here is our contract curve. Okay. So let's just say this point is some C and this is some D. Now, let's say that the consumer's efficiency point that we arrive at is this. Okay. And the price ratio which goes through here is this. So this is our Px by Py. Okay. And this is our contract curve from consumption, right? This one is our PPF. Okay. And this is the equilibrium in consumption. Now, we want to have C, point C, as our equilibrium, and we are also going to show D as the disequilibrium. Now, if I state before drawing anything that D is a disequilibrium and C is an equilibrium, then what it basically says is that the price ratio that goes touching the point C, that is tangent at C, that price ratio, okay, it can be anything, but to have an equilibrium, it has to be parallel to this price ratio. Okay, so let's try and draw a parallel line. Okay, so here we have, right? All right, so this is our price ratio. It is such that this straight line, this price ratio, is parallel to this price ratio, which guarantees that at C and at this point, let's say this is E, we are looking at the same price line. Okay, the same relative price. And that says that if that happens, then okay, C is an equilibrium. And in D, let's say we have a price line, which is anything, which is like this. So at D, therefore we have a disequilibrium. Okay, so that's the understanding of the condition that we have written mathematically. Okay, so I'll just mention it again. So this is consumer's equilibrium, and that point on PPF will guarantee that the equilibrium where the passing price relative price line, the passing price ratio, this line will be just parallel to the price ratio that is there at E. Okay, so if they are parallel, so I have C as an equilibrium. Okay, so to write, so at C, this is what is happening. So at C, the common slope of MRS is or equals equal to that of PPF. Okay. Okay. So, what is the economics behind it? As I said, that at C, the rate at which X is being transferred to Y is the same rate at which X is exchanged at the same rate. X is exchanged against Y. So, our transformation rate is getting equal to the willingness to exchange. Okay, and that guarantees the equilibrium. So nothing at all is wasted. If they are different, what essentially will happen is that you may produce by transforming X into Y. Let's say you are sacrificing 1 unit of X and you are producing 2 units of Y. If that rate is not equal to the rate here, okay, if you are not at equilibrium, then it may happen that against that X, okay, the consumer who is leaving that 1 unit of X may be ready to just accept 1 unit of Y. And in that case, what will happen is this: the 1 unit of Y that is being produced will be kept as a leftover. Or otherwise, what I might say is that the full potential of producing Y, sacrificing 1 unit of X, will remain unutilized. And that is something which is inconsistent with Pareto efficiency. So Pareto efficiency essentially says that there can be no wastage at all. Okay. Okay. Now we will go to the mathematical description of this general equilibrium. Now, unlike consumption and production, here we'll be considering all of them together. And that consideration will have something extra, something that we have not assumed earlier. Here we will, okay, so mathematical statement, right? So here we will have something extra. So that something extra is, number one, is resources are owned by consumers. So by that we mean resources, we mean labor and capital, right? So that they are owned by consumers, something that we have not discussed when we discuss production. And also, since you can't be letting the farm using your resources for free, there will be this profits will be shared by the consumers. Okay, so that kind of is that seals our economy. So there are consumers who owns resources, who will let them to be used at some given input prices. Okay, and the farm will produce things, and by that production, farm will do that in keeping in mind profit maximization, and the realized profit will be shared among the consumers, or between, here I will consider two. So between the consumers and the production, the transformation rate of that production will be equal to the rate at which these two consumers are willing to exchange. So that's our total structure. It's quite huge. Yes. So I'll just go at it again. So consumers owning resources, labor and capital, renting them at a given price from the input market, taken from the input market, to the farms. Farms are profit maximizers. They are producing using these resources and making some profit. Now, since resources are supplied by the consumers, they are sharing that profit, and the production is happening at such a point on the PPF that the transformation rate of X and Y is the same with the rate at which consumers are willing to exchange X and Y. All right, so that's our general equilibrium. That's natural because it's general, so it is meant to be quite huge, right? Okay, so keeping that in mind, first job of us is to introduce notations. So we'll be using notations that we used earlier. So two consumers, A and B, and their resource. So there will be LA, KA, and LB, KB. Then comes two farms, F and G. As I said earlier also, that here to keep it things generalized, we are taking two farms, but you can encounter problems which will have only one farm, okay? And that doesn't change anything apart from the profit calculations probably. Okay, so F and G with employment levels. LF, KF, LG, KG, right? Okay. Now we denote goods here. So two goods. We denote them as X1 and X2. So you can interpret them as good 1 and good 2 producing X1 amount and X2 amount. Right? The standard way of saying things. Okay. Now look at the profit functions. So these are our notations. Let's go to the profit functions. So profit for farm F, that is revenue, right? Okay. Minus cost. And similarly, so it is for farm G. So F will be substituted by G. And as I said, W and R are given. Okay. So the consumption bundles, they will be in general, the consumption bundles will be just like what we have written earlier. So XA1, XA2, then XB1, XB2, and the new thing, that is share of profit. So for that it will be SA1, right? Or should I introduce farm? So SAF, right? SAG, and then SBF and SBG. All right, so what does it say? Let's just go at it. Okay, so SAF, that is the share of profit of A from farm F, share of profit of A from farm G, and so is for individual B, right? So from F, from G. Okay, so these are our set of notations. All right, so now we will move on to defining the equilibrium and writing the equilibrium conditions. Now, just before going, I will say that so these are in general notations, right? And in equilibrium, to write that it is equilibrium, we'll just put a bar on them. So there are price P1 and P2. At equilibrium, we'll denote as P1 bar, P2 bar, and so is here X1, XA1 bar, XA2 bar, and so on. All right. So let's write it. Now first, we will write what will constitute our equilibrium. That is, what are the values, what are the magnitudes that we will get at equilibrium, and then I will write the conditions. All right. So at equilibrium with prices P1 bar, P2 bar, then resource prices, or if you like, input prices W bar, R bar, okay, and then optimal consumption XA1 bar, XA2 bar, XB1 bar, XB2 bar, output XF1 bar, XG1 bar, XF2 bar, XG2 bar. All right. Or shall we go farm wise? So let's go farm wise. So F2, I'll write it G and 1. Okay, so this is farm 1's output at equilibrium. This is farm G's output at equilibrium. This is A's consumption at equilibrium. This is B's consumption at equilibrium. And these are the equilibrium prices. These are the input prices. So this is a complete set of magnitudes that we will get when we'll solve a complete problem of general equilibrium. That said, definitely the solution will be lengthy. All right, so conditions. So what kind of conditions they will satisfy an equilibrium? So conditions satisfied. So what are they? Okay, so we'll just bring in some of the conditions that we have mentioned earlier with respect to consumption and production separately. Number one is that our optimum bundle here, so this pairs, okay, they maximizes utility. So they maximize utility. Now with share of profit, the budget constraints are changed with budget constraints. So they will be changed, right? So they are, here is our expenditure at equilibrium. Which cannot exceed the money that A has, both from resources employment, so payment to the resources, and from the share of profit from the two farms. And yes, as you can imagine, that in equilibrium, they will be same. So I'm not going to write the second one. You can replace A by B and you can get the conditions that needs to be satisfied. All right. So let's go to the production now. So in production also the same thing will be required. That is, these output vector, they will be profit maximizers. So number 2 is that XF1 bar, XG1 bar, or okay. So we'll go farm wise, sorry. So for farm F and for farm G, these are profit maximizers, right? Okay. And the third is the satisfaction of demand and supply. This will be the satisfaction of demand and supply, or as we say, availability and final allocation. So for capital, they must be equal, as supplied by consumers must be equal to employed by farms. So will be for the labors, And then we have some constant that we have seen earlier. So xf1 plus xg1. So this is the production amount of x1. It must be equal to the demand that is made of x1 by A and B. And the same thing goes for 2. Okay, so just to repeat it again, this is capital supplied by the consumers equal to the capital that is being used by the farms. This is same for the labors, and this is where now the supply is basically done by the farm. So supply of x1, all right, at equilibrium, that will be equal to the demand generated by the consumers as a final allocation, and this is the same thing written for good 2. Okay, so this is the complete mathematical statement. And after writing this, the natural question is, or the natural progress is to go to the statement of the theorems in general. Now, in general, obviously, the statement, they don't really change, right? So the first welfare theorem in general, so the first theorem in general says that competitive equilibrium, that is Pareto efficient, right? And the second theorem also said the same thing, which it said earlier, that if we want to go from Pareto efficient to competitive, so if we want to make this journey, then we need to add something, right? So here we have to add, either you can say convexity, or you can say suitable redistribution. So suitable redistributions. In effect, they are basically the same. Okay, this is in terms of mathematics, and this is what we want by economics. Okay, now, so this completes our discussion of general equilibrium. And so we have the efficient outcome, right? Now, from the very first session, I'm saying that not all efficient points are equally desirable. Right? So a complete ownership of a single individual and zero ownership for all the others in a society will be quite Pareto efficient. So that can arrive as a solution of this general equilibrium. But that is so undesirable, right? On equity consideration. So what about desirability? What about desirability? About which G says nothing. So obviously, first we will guarantee efficiency, and then we are now interested in desirability among different choices. This is a question of welfare economics. This is something that we are going to learn next.